Okay. Our first presenter today is Meg Dodge, a doctoral student in chemical engineering. Her presentation is titled, Beyond the Breakdown, the Environmental Impacts of Micro and Nanoplastics from Consumer Products. Let's have a big round of applause for Meg.
Thank you. Every morning, I wake up, brush my teeth, have breakfast, go to work, have lunch, eventually go home and eat dinner, do my dishes, and then finally curl up in bed with a nice book and my gorgeous retainers. There is nothing super interesting or unique about my day, but all of these steps have one thing in common: plastic. Plastic is everywhere, and even though we may try our best now to avoid it, we interact with it every single day. We know that a lot of this plastic ends up as pollution in the environment, and it seems easy enough to just pluck it right out. There we go, no more plastic pollution. But what does this plastic leave behind? If we zoom in, we can see tiny pieces of plastic called microplastics that are in our soil, our water, and even our air. And if we look even closer, we can't really see it, but there are nanoplastics. These are so small that they're invisible to the eye, and 80 of them can fit lined up between the ridge of our fingerprint. However, the plastics manufacturers, they're here to save the day. They've developed new plastics called bioplastics. These are based from plants or other natural materials, and we're often bombarded with advertisements with buzzwords for these like green, compostable, biodegradable, or my favorite, sustainable. So let's look at our pollution scenario again, but this time with our green plastics. Here's what they tell us happens. These plastics biodegrade, and poof, they're gone. But we know better than this. We know to look closer, and when we do, we see microplastics, and even closer, nanoplastics. This brings me to my core research question, which is, are bio-based plastics inherently better than their fossil fuel-based counterparts? The first thing I wanted to do for this project was investigate the degradation of both bio and fossil fuel-based plastics in fresh water. We hear a lot about plastic pollution in ocean water. The plastic that we pollute into the environment can travel through river systems and eventually end up in the ocean. And when it does, it looks almost the same as when it was first produced. But we know that this would not be the case for bio-based plastics. They would degrade into micro and nanoplastics in these river systems before they ever got to the ocean. So I wanted to design an experiment that compared the degradation of fossil fuel versus bio-based plastics in fresh water. To do this, I used 3 plastic types. The first is fossil fuel-based, polypropylene. For this experiment, I used straws. They're consumer-based plastics, and they're easily accessible. The second 2 plastics I used were bio-based. These are polylactic acid, or PLA, and Ph.D. I won't try to pronounce that in front of you all tonight. I put each of these plastics in river water from Mary's River for 170 days, and here's what happened. The only plastic that showed significant degradation was the bio-based Ph.D. We can see that here, it was the only plastic that produced a significant amount of microplastic particles. When we look at the nano level, we see something similar. These lights here that sort of look like stars in the sky are actually nanoparticles. And we can see that there are more nanoparticles produced in this bio-based Ph.D. solution than any other combination. But this is just a small snippet. If we look at all of the data, we can see the same thing. Along the x-axis here, we have the plastic size, and along the y-axis, we have the concentration, or particle count. And we can see here in the blue that the Ph.D. produced more nanoparticles, again, than any other of these combinations of plastic solution. My hypothesis going into this research was that the accelerated degradation of bio-based plastic would lead to more micro and nanoparticles compared to fossil fuel-based plastics in similar conditions. And that's what I've shared with you here. But I have other questions as well, like what will these plastics do when they're in the environment? What organisms will they interact with? Will they interact with other contaminants like heavy metals or PFAS? Will the accelerated degradation lead to other chemicals in the environment like fillers and additives that are in these consumer plastics? And finally, will this accelerated degradation lead to even more challenges when it comes to taking this plastic out of the environment? So I'll leave you with this. Before we make the switch to these green plastics, we have to consider, is bio-based really better? Thank you.